Hello everyone, and welcome to today's webinar. My name is Thomas Pickering. I am a product engineer for OpticStudio here at Zemax, and the title of today's webinar is Creating Sequential Systems with Prisms, CAD Parts, and Other Complex Objects. One important category of optical systems is one that is basically sequential, but can also contain other elements that require a much more complex non-sequential ray trace. If you have a system like this, you would need to set up a sequential system so that rays can start on a sequential object and finish at a sequential image plane, but in between, rays can also go through any number of non-sequential components. And over the course of this webinar, I will show you how to set up such a system. So as I mentioned, this way you can model both sequential and non-sequential ray tracing in the same optical system. And such a system is called a hybrid system. This is very often used for systems that have total internal reflection. For example, if you have fibers or prisms with any type of optic in between. And I will show you how to set up a system that will use both a light guide and a prism. So the way this is modeled, we have a special sequential component, surface type that's called a non-sequential component. It's a single surface that will represent a group of non-sequential objects. All of these objects are either three-dimensional shells or solids. And you can define them like you would in a normal non-sequential system in a 3D coordinate system. The rays then enter the non-sequential group through a so-called entrance port and trace non-sequentially through the group and then leave through the exit port. Okay, so I'm going to show you how such a system would look like. We have several of these systems as an example shipped with the software, and we can just open an example, which is under samples, non-sequential. Then you go to prism, and I'm just going to open one of these, and it's the Passion prism. So as you can see, the lens data editor, I'm going to move this, make this a little bit smaller so you can see a little bit better. Lens data editor shows that the system is essentially a sequential system where the rays start from an object, trace through the stop, and then all the way down to the image plane, and in between is a non-sequential component surface. This surface is the so-called entrance port. And this is the point where the rays enter the non-sequential component to then trace non-sequentially afterwards. This is basically a standard surface and can be non-planar, so you can actually put in a radius. And you then use the non-sequential component editor to define any number of objects or any type of object and any position of the object. And this is a so-called group of non-sequential component. Yeah, all objects within this group then share a common coordinate system that refers to the position of this non-sequential component surface. The surface that's immediately after the non-sequential component is the so-called exit port, and this is the, if you will, the so-called hole through which the rays will leave the non-sequential group, and after they pass through this surface, the rays just continue to be traced sequentially. One important point is that the semi-diameter of the surface that comes after this non-sequential component defines the size of this exit port. So the location of the exit port is defined by the parameters in the non-sequential component surface. So if we move over in the lens data editor, just expand the columns a little bit. So if you move over, first of all, you've got a flag here that says draw ports. With this flag, you can show the entrance and exit port on the layout plots. The next three parameters are the exit location X, Y, and Z, and they define the X, Y, and Z coordinates of the exit port. And then you've got the exit tilt, Y, and tilt Z, and they define the tilt of the exit port about local axes. And both these groups of parameters are with respect to the entrance board, so with respect to the location and orientation of the non-sequential component surface. So basically, the non-sequential component acts like a sequential coordinate break surface. Finally, the last two parameters are the order and the reverse raise parameter. The order flag serves has the same purpose as within a coordinate break, and it determines whether the decenter is done before the tilt or after the tilt. So if it's set to 0 or to 1. And the reverse raise flag, if the component group within the non-sequential component is a lens, also act as a lens, so it's basically going from left to right or going through, so which would be a flag 0, or it's internally reflected and acts as a mirror, which would be something, anything not non-zero, so it would be a 1. The reason why I opened this example is that prisms are a particularly good case for a hybrid non-sequential mode, because rays undergo a very complex path and they do different things at the same location depending on the incoming angle. So when you look at this prism here, that depending on the angle, the rays either reflect or transmit. So you've got 1 and 2 times the reflection and the transmission at this particular point, and that's at the same location, so at this air gap here. Prisms can be defined in several ways. You can either have a CAD object or you can have a polygon object. In this particular case, it's a polygon object. It's already designed here, so it's this Peshen polygon object. We can have a look the way this is created. As you can see, the non-sequential component sits on surface number 2, and this can also be seen in the non-sequential component editor. In the top title bar of the tab, it tells you that the component group is the component group referring to surface number 2. So now I've got one component group in my sequential, or essentially sequential system. And now I would like to show you how you can set up a system that has two component groups. So we're going to build a system that starts off sequentially at an object plane, goes through a light guide, or a light pipe, sorry, and then we're going to use a couple of lenses, and then we're going to go through a prism and finally end up at the image plane. Okay, so let's start with a new system. Okay, so like we always do, we start with an entrance pupil diameter of, we start with an aperture definition, set the entrance pupil diameter to 5, and I'm just gonna insert a few surfaces, and starts with a distance of 10 millimeters. Let's expand, make the columns nice and fitting. And the next surface is going to be my non-sequential component. Just start typing non-sequential and select your non-sequential component. As you see, as soon as you put that one in, the surface directly after the non-sequential component has its semi-diameter fixed. And as I mentioned, this is because this defines the size of the exit port. So now my non-sequential component surface is my entrance port, and we need to define the location of the exit port. So I will set my exit location in X to 130, my exit location minus 130, my exit location in Z to plus 130. Yeah, so just size of my light pipe. So the first element is going to be my light pipe, and I'll leave the other parameters as they are by default. So now the distance, so now my exit port of size 2.5 is located these distances away from my entrance port. Okay, so before we insert a non-sequential component, let's just set the size of my exit port a little bit bigger. I'm going to set it to 20 millimeters. And now we can enter a non-sequential object or component group. So I'm just going to click here, the non-sequential component editor. And we're going to drag it down so we can see both at the same time. So the first element, as I said, is I want to have a light pipe. And I'm going to build the light pipe out of 2 torus volumes and 1 cylinder volume. So gonna start typing torus volume. I'm gonna set again, resize my columns a little bit. X position is going to be minus 49.5. The Z position is going to be 20. My material, I'm going to make NBK7, yeah, and the rotation in R will be the curve radius of my torus volume. I'm going to set this to 50, and the radius R, the small r, is the internal radius of the actual pipe. I'm going to make that 5 millimeters. Start angle is 0. Stop angle is 90, so it's just a corner object, and you can see what that looks like if you click the view current object. Yeah, so we made a 90-degree segment that looks like this. Now I'm gonna connect to this. I'm gonna connect a cylinder volume. So with Control Insert, we're gonna add a object after the first object. This is going to be my cylinder volume. Yeah, position here is going to be minus 80.5. Set position is 70. I need to tilt it a little bit about Y by 90 degrees so it's upright. And again, I'm going to make it out of NBK7 so that the size matches. My front radius is going to be 5 millimeters. My length, I'm going to make it 31 millimeters long, and back radius again 5 millimeters. And then finally, I'm going to copy my torus volume and paste it. So I only need to adjust the coordinates. So again, minus 80.5. Need to change the Z position to 120 and the tilt about Y to 180. And as I said, the rest will be the same. So now I can look at my layout plot and see if that all looks okay. So let's look at my 3D viewer. I'll pull it out so you can see it a little bit better. I need to flip it. Actually, let me just choose the XZ plane. So you can see I choose a random, make 15 rays. So you can see that the rays start at the object plane, and the object plane is directly at the stop. They go through the entrance port, and then from the entrance port they go through this double curved, this S-shaped light pipe, and you can see they now have total internal reflection and exit the final object, and they trace all the way to what is here called the exit port. And you can see that this is the case by, if you click this one, this is my non-sequential. You can see here that we've got the non-sequential component, so-called entrance port, is highlighted here in orange, and the exit port is this one here, which is identical with currently my image plane. Yeah, so now we've got the first non-sequential component group, so our first object group defined. Again, you can see that the surface number 2 is the one that's taking these objects here, so you can see this here on the top of the tab. Before we go to the next non-sequential component, I'd like to put a few sequential optics in. You can use any type. You can use now any type of lenses or gratings, but just to make it easy for myself, I'm just going to put in 2 paraxial lenses, one to sort of roughly collimate the light after the light pipe, and then one to focus it down before we send it through a prism. So again, I'm going to insert a couple of more surfaces. Yeah, so I want to have a lens about 10 millimeters after my exit port. I'm going to choose as I mentioned, a paraxial and another paraxial. Yeah, the first one will have 40 millimeters distance to the second one. I'm gonna make the focal length of the first paraxial lens 20, yeah, so it matches this distance. Sorry, the distance from the exit of the last object to the beginning of the lens. So we now have got a rough collimation, and then the second one has a focal length of about 50. And yeah, and then we're gonna set about 20 millimeters to the entrance port of the second non-sequential component group. And yeah, so again, if I open the viewer, this is not no surprise what's gonna be here now. I'm gonna again make this random and set about 15 rays so we can see. Yeah, so now we have, this is the exit port, this is my first paraxial lens, this is my second paraxial lens, and then here is my current image plane. This is where I'm going to put my new entrance port. Yeah, obviously you can update this a few times. Alright, so let's enter our second non-sequential group. The size of my second exit port I'm going to make 50, because yeah, just to be on the safe side, we trace all of our rays. Again, I'm going to go over and locate my exit port, and I'm going to set the exit location to 0.07 in Y and 100 in Z. And finally, before we enter the second non-sequential component, I'm just going to set the distance to the image plane, and I'm going to set it to 20 millimeters. So now I am ready to enter my second component, and as you can see, as soon as I entered the second non-sequential component, I now got the section here on the non-sequential component editor that tells me which surface I'm currently viewing. So if I click over here, I get surface number 6, same as down here. And now I can enter an object here. I will simply copy the passion prism that I showed you earlier. Just gonna enter a polygon object and select the passion POB, so the passion polygon. Where is it? Here. And click OK. Because the polygon is defined with a front side length of 1 millimeter, I will scale it with a factor of 30. Yeah, so we've got a 30 millimeter edge length on the front. It is a volume. I'm going to apply a material to be NBK7. And one thing, we need to change the Z position to about 0.5 millimeter. Yeah, so just viewing this object, you can now see I've got a Passion prism where the front entrance is 30 millimeters by 30 millimeters. Okay, so let's close this one and let's have a look at our 3D viewer. And I apologize that I closed it again. I have to set this up again with our viewer. So change it to 15 rays again and to make it random again. And yeah, again you can see here my S light guide. I'm going through my double paraxel lenses. Here at the front of this prism you can see the entrance port. At the back you can see the exit port and then the image plane. This view is a little bit confusing because the prism's not upright. Let's tilt it up a little bit and you can see now, let's actually use this YZ, you can now see this prism behavior where rays hit the air gap reflectively, then transmit through here and again reflect off here until they hit the image plane. Yeah, and if you update, you can see that this is now a nice non-sequential behavior within a sequential group. Yeah, I hope that this has been useful. A few things. Mixed mode is, as you can see, is a very useful way of combining sequential and non-sequential ray trace. There are a couple of limitations when you use a hybrid mode. So ray fans and OPD fans can potentially be meaningless because of the sort of like random nature of ray tracing within a non-sequential component. In this case, image analysis is something that you use. Optimization and tolerancing are fully supported in this mode. However, defining merit functions is a little bit trickier, so you shouldn't use Gaussian quadrature when defining a merit function. Thank you very much for listening. If you have any questions, please ask them now via the GoToMeeting interface, and I will do my best to answer them.